I am, as was said, Ben Hale. I am a Pivotal employee, one of the few Cloud Foundry developers that doesn't actually live here in San Francisco. I live over in the UK. So if it's already after lunchtime for the East Coast, it must be about bedtime as far as I'm concerned. And so as was said, last year, I talked a little bit about the Java Buildpack, because so many developers working against Cloud Foundry are developing Java applications. We take a very, very strong interest in that particular experience. And last year, we introduced the Java Buildpack and some of the new features, things that it could do. And this year, I wanted to do sort of a year in review, discuss where we have been, what we've been doing since I last spoke to you. In truth, it isn't a year in review. It's actually 9 months. So keep that in mind as we take a look. Just some statistics about it. 420 commits since the last conference. That works out to about a commit and a half a day, including weekends and holidays. So we're sort of very steadily making changes as we go. Those changes sort of all fall into a couple of buckets. Updating existing functionality, expanding this list of supported platforms. One of the things that I'm really, really proud of is how much change we've had that's been driven by the community itself. I come from a very long open source background. I started as a core committer on Spring back in 2006, probably. So for me, the more that the community gets involved and tells me what they want to have, what they want me to make them, the better I think I'm doing at my job. We've updated 228 different dependency versions. Most people, okay, it's a dependency version. That doesn't really mean a whole lot to most developers. But for Cloud Foundry developers, or specifically for people who run applications on Cloud Foundry, Java applications on Cloud Foundry, this is actually a really, really big deal. Because one of the key design points of the Java Buildpack is this idea that things are secure by default, right? We're really, really aggressive about making sure you've got the latest patched versions of the JRE, that you've got the latest patched versions of Tomcat, if you choose to use that, right? And so the fact that every single Monday at 2 o'clock in the afternoon, I close all the other work that I do, and I start going through a list of every single dependency that the Java Buildpack uses, and I look for what's new, right? Find out, maybe there's a new version of the App Dynamics agent if you're a user of that. Make sure that gets uploaded so it's available to you. Maybe Oracle has decided to release both another Java 8 and another Java 7 on the same day, and I have to build them for 5 platforms, and each build takes 4 hours to do, and blah, it's horrible, horrible. But I do that for you guys, right? We want to make sure that every single week, every single day, you have the safest possible environment to run your applications in. We've also added support for a bunch of new OSs. CentOS 6, I know there are a lot of CentOS users out there, a lot of enterprises especially, who consider CentOS support to be a deal breaker. So we support that with the Buildpack. Also trusty to hear, so we are ready for the great migration to a modern operating system inside of Cloud Foundry's default behavior. Mavericks is mostly for me, but this goes into, this is in addition to the Lucid Lynx, Mountain Lion, and Precise support that we've always had. So, a pretty broad selection of operating systems that the Buildpack will run on when you choose what stem cell you want to use. We've done a lot of work in auto reconfiguration as well. Auto reconfiguration was great. It was a great demo last year. Much to my surprise, actually, a lot of customers are asking to use auto reconfiguration in sort of production circumstances rather than demo circumstances, which is what I would have guessed for. And so we took the opportunity to sort of re-examine how exactly we do auto reconfiguration for Java applications, especially Spring applications, how we can make it a bit more robust, and most importantly, how we can expand the support of auto reconfiguration. So if you're a Gradle user, you're probably familiar with the dist-zip style application. We can now do auto reconfiguration on those. One of the big ones that really took me a long time to get to grips with is support for Servlet 3 applications, if you're developing those as well. If you're a fan of Spring Boot, and if you're not, you absolutely should be. If you're a Spring developer, anything that makes developing microservices easier is going to be a really, really big deal. So Spring Boot applications, we're waiting on a 1.1.0 release. I noticed this morning that the binaries for 1.10 are actually up. I'm not sure if that's been officially announced, so I may be letting the cat out of the bag. But as soon as I can get back to a computer, we'll have support for auto reconfiguration for those applications as well. We also did a lot of work in the area of how you extend the Java Buildpack. The Java Buildpack from day one has always been designed with very well-defined, well-documented extension points. So if I haven't done something that you want the Java Buildpack to do, you should be able to very, very easily write it yourself. Hopefully you'll contribute it back. Again, this is a community, and I love those kinds of contributions. It was the major feature in version 2 of the Buildpack. And the reason we had to go to version 2 is because it was compatibility breaking. It's not something that we took particularly lightly to break that compatibility, but we're really, really happy with the result because it gave us a form of sandboxing. So now components inside of the Java Buildpack can't interfere with one another unless they're really, really trying hard. It's not foolproof, but it's going to keep honest people honest. We've got nice application and droplet abstraction, so now you don't have to worry about making sure files get to the right place inside of your application or inside of your droplet, how you add arguments to, say, Java ops or something inside of the droplet as it's run. And in practice, we had a nice little thing. I'll talk a little bit about it on the next slide. We have a fork of the Buildpack that I'm quite happy about, where they had implemented a new container for JBoss right before we made this change. And then we went in and took a look at what would have happened if we had made this change, or when we did make this change. We found out that it actually reduced the amount of code in that fork, that custom code that was different than the Java Buildpack, by 50%, both on the production side, but more importantly on the test side as well. As I said before, one of the things I'm really, really proud of is all of our community contributions. This is just sort of a couple of highlights: support for HTTP and HTTPS proxies. So I know a number of you run in enterprises where you've got proxied internet connections. Now we support something like that. Improved Tomcat container logging. This was actually a very long and drawn out. I don't think I've ever had a GitHub issue that was as long as this particular one, as Guillaume and Mike and myself all sort of hashed out what logging should look like from the Tomcat container inside of Cloud Foundry, how we hook that into LoggerGator and make it easily identifiable. And then, as I said before, we had a great contribution that's now in the Cloud Foundry community organization of a JBoss Buildpack fork. So we do have the ability to run applications in JBoss as well, if that's something you're interested in. But there are two more features that I want to discuss in a bit greater detail. And as I am the token technical keynote here today, I want to do some live coding with you guys. And the first is around session replication. As we go into the cloud, most people, I think most developers, realize that you've got to move more or less to a stateless architecture, right? If you want CF scale to work properly, you can't be sharing a huge amount of data between different instances. Or if you are sharing that data, it's got to be pushed way, way down into the data tier, something that was programmed to be massively concurrent, massively scalable from the start. But we also find that there is a need for some session replication. And so basically what that means is when an HTTP session is created, we need to be able to keep it around. And if, for example, an instance goes down because you're doing some sort of rolling upgrade, or you have to restart your application, you want someone's session to come back, we do need some sort of support. So the Java Buildpack does actually now support replication of HTTP sessions into a Redis backend. The code itself is ASL v2 licensed, which means that you guys can use it outside of Cloud Foundry if you want to, and isn't particularly tied to Cloud Foundry. But one of the really nice things is we have zero-touch configuration. If you have a Redis service bound, and that Redis service has session replication somewhere in its name, we're going to say, oh, you must mean that you want to do HTTP session replication to it. So we can take a look at some demonstrations of that actually working. So I have an application actually running right now. And that application, I apologize for how small this is going to be. I really have to find a better tool for this. Allows us basically to send a piece of data, and it's going to store that particular data into a session. And so in this case, we're just going to send a string that says hello world. If I go ahead and grab the cookie string from it, put it in here, we should see that particular data come back. But if we restart that application, now, what we expect to see is, by default, Tomcat doesn't store its sessions any place particularly useful. It's stored mostly in memory, and there are certain circumstances where it might actually be written out to the file system. But in general, it's not going to be persistent. And so when this comes back up, while we're waiting a little while, there we go. We'll see that when I run it this time, we get a blank response. So that's not great, right? If your application, you need to scale up a new number of instances or something like that, all that data going away isn't great. So now we'll go ahead and bind that service, a Redis service that I have behind the scenes, and we'll go ahead and restage this. If any of you guys remember last year, if you were there, I'd like to do my demos against run.pivotal.io. I find it makes me very sensitive to how it performs. And last year, it was having a bad day, the day of the conference, actually. And I was very, very worried. In the end, it all held out, but I'm happy to say that these days, it's incredibly stable, and we have almost no trouble with it. And hopefully, this will go quite smoothly here. So the application, so as we got to stop here, what behind the scenes actually happens is when we build the Tomcat instance that's going to run inside of your application, we use something called a Tomcat persistent manager, and we have a Redis-based store. And it replicates sessions synchronously back to that back end. And it turns out, I mean, I certainly am not a fan of session replication personally. And did this only because I was asked to. But it turns out that the performance isn't absolutely horrible. Obviously, it's contingent on network and any number of other things besides the data that you're actually persisting. But we see that it's something like, we're using Redis to go here, the Redis Labs product. So it's, sort of all in S3. But we find that it's tens of milliseconds kind of delay. So it's not the end of the world to do something like this. So we'll go ahead and persist data in again, grab a new session. And if we run it, we see the data is there. And if we restart our application, we should see that the data comes back up once again. So let's hope so. Maybe. It was actually surprisingly difficult to create a demo that would show this, because Cloud Foundry's sticky sessions are so darn good. Trying to get to another instance that doesn't actually have the session already stored inside of it was really difficult. And so there we go. We see the data itself. So it survived a restart of the Tomcat container. And you guys have access to that, whether you're providing your own Redis service or if you're using one of the ones packaged out of the box. So the next thing I want to talk about is Buildpack Packaging. This has long been something that was contentious for me. Not a huge fan of it when it started, when the work started, when the requests came in. But I've grown to actually love it quite a bit. And it's all contingent on the fact that we now have this command called cf create buildpack. It has a bunch of different names depending on sort of when you learned about it. A lot of people call these things admin build packs, things like that. I prefer to think of them as build packs in the only way they really should exist. And this allows you to take a zip file, basically just some discrete bundle, and upload it into Cloud Foundry. And that gives a name to this bundle. It doesn't have to be stored in Git or in any other version control system, although I highly recommend you do that. But it allows you then to create it, version it, update it. And every application that uses this particular build pack then has access to it. And inside of the Java build pack, it led us into this idea that there are actually 3 different styles of using a build pack. The one that I was originally most a fan of is this online mode, what I would refer to as easy mode. And this is what the Java build pack does out of the box. It goes and says, OK, what's the latest version of Java? Let me go get that. And it goes and gets it, and it drops it onto into the droplet and used for your application. But it turns out that that's not necessarily possible in a lot of cases, especially inside of enterprises. Going to the internet is a no-no, right? Certainly on any sort of production system, they need to really control, sort of external access and things like that. And so there's this hybrid mode that sits in the middle. And this hybrid mode is basically an online mode, except rather than going to our repository for dependencies, you create your own repository for dependencies. And we've done a lot of work and worked with a number of customers on how to get this done. But the big upside of this is then that we now have a one-liner script that allows you to replicate our entire repository locally on your machine. You can decide how you want to expose it as far as static files and things like that. And then use the Buildpack pointing at that instead of download.run.pivotal.io. And the final one, and the one we're going to discuss a little bit today, is this offline mode or self-contained mode. And the offline mode is exactly what it sounds like. The Buildpack never goes to any network connection at all. And we do this basically by faking a cache, filling a cache as part of a build. So in the online mode, we're always going to a network trying to find the latest version of a dependency, depending obviously on how you've configured it. Requires network access. The offline mode, no network access required at all, which is a huge benefit for a lot of people, but it does then put the onus for updating and keeping secure on you, the user, right? The person who's maintaining the Buildpack. So let's take a look at an example of that. So the Buildpack itself, Java Buildpack here, oops, has basically Rake inside of it, which is a build system. And we can run a command and say we want to package this, and we want to package it for offline usage. And when we do that, it then basically takes a look at the Buildpack, takes a look at all the configuration you've set in the Buildpack, and says, OK, if I was going to run inside of a droplet today, what would I go and download? But it does it for everything, not for a particular application, which means that it needs to go get all of the possible things. If you might one day want New Relic is going to go get that, or if you might want App Dynamics, it's going to go and get that. One of the more interesting things is it goes and gets 5 different versions of the JRE, not knowing exactly which operating system. But all this stuff gets downloaded based on today. Right? And it gives you a nice little zip file at the other end that you can go ahead and upload to your Cloud Foundry instance and use. And this will finish in another couple of seconds, but since I'm running a bit low on time, I'll go ahead and create a Buildpack here using one that I have cached earlier. And so an offline Buildpack runs you, I think today, in the order of about 200 megs once it's all filled up. If you want to prune that, it's easy to change inside of the Buildpack packaging mechanism and say, I don't want this thing, I don't want this thing, I'm not going to run App Dynamics, I'm not going to run New Relic, something like that. All that stuff can go away. So now if I type Buildpacks, I see that there is my test Buildpack here. And so if I cf push that, push an application there, the giveaway, the way you know that an offline Buildpack is being used is A, it will tell you that it was packaged as an offline Buildpack nowadays, but also that it never actually goes and looks on the network for things. We've decided to become a bit more descriptive about telling you when we've used a cached artifact rather than going out to the internet, so it's a little bit clearer. So we see that this is, in fact, an offline Buildpack, and we see every single dependency, whether it's the JRE or it's Tomcat somewhere in here. Tomcat, here we go. All of those things are found in the cache, and so that's how an offline Buildpack works, is by basically pre-populating a cache before your application actually uses this particular Buildpack. If we had done an online Buildpack, it would have shown that it would have taken a couple of seconds to go download each one of those things instead. So packaging is there as well if you choose to use it. Certainly, I have come around on this, and I think the packaging Buildpacks and certainly the create Buildpack, update Buildpack commands are really, really useful, and I highly encourage everybody to use them. So as I have mere seconds left, the stuff we discussed today, just a little bit. There's all sorts of stuff that has happened in the Java Buildpack over the last year. I'm happy to have been a part of that, and I'm happy to be a part of it for the foreseeable future. I love it when you guys in the community tell me what you want, right? Community contribution means a lot of different things to a lot of different people, certainly to a lot of different organizations in this room. But for me, I love issues, right? Even more than I like pull requests, although I'll happily take them from you as well. I like you telling me what I should build, and I'm happy to build it for you if you want it. OK, thank you very much, everyone.